Good morning, students. So, atoms chapter we were discussing. In the last class, we discussed two derivations. Hope so you don't have any problem in that derivations. You have revised that. So, today I'll upload those derivations. Please go through that, okay? Okay, so today we are going to see the next derivation part. So, before going to start the next derivation, last two derivations, once I'll write and keep so that in another continuation part, you can refer that, okay? So we have discussed about the radius of the nth orbit. For the radius of the nth orbit, we have the expression Rn is equal to epsilon naught n square h square divided by it is m into e square. This is for the radius. Okay, so this is for the hydrogen atom, because if you consider the hydrogen atom, Z is equal to 1 agate. If it is not a hydrogen atom, then here Z will come. But here the Bohr's postulate, what it says, it is applicable only for the, that is for the hydrogen atom, right? So here the energy expression, if we see the energy, the total energy is the sum of the kinetic energy and the potential energy. So if you see the expression for the energy, it is given by, it is m minus m into e to the power of 4 z square divided by 8 epsilon naught square n square into h square. Okay. So with respect to the orbit, means first orbit, second orbit, you can substitute the value of n. With respect to the atom, you can substitute the value of the z. Okay. So this is for the energy. So other than this kinetic energy and total energy relation, that all we have discussed in the last class. So today we are discussing the frequency expression. So what is the derivation for the frequency, or you can also take it as the wavelength also. Okay. Because frequency and wavelength relation, if you see, frequency ಮತ್ತೆ wavelength relation ನೋಡಿದ್ರೆ, frequency is equal to, so frequency nu ಇಂದ denote ಮಾಡ್ತಾರೆ, frequency is equal to C divided by lambda. Okay, or you can write it as F is equal to C divided by lambda. Okay. Yes. So now here, what is wave number we will discuss. What is wave number? What is wave number? So wave number is denoted by the letter nu bar. So the wave number is nothing but that is the reciprocal of the wavelength is called as what? Wave number. So illon definition ಹೇಳ್ತಾ ಇದೀವಿ ನಾವು, that is the reciprocal of the wavelength is called as what? Wave number. So this is wave number. If you want to write the definition, the wave number is equal to number of waves. Wave number is equal to number of waves upon length. Number of waves upon length. So that is nu bar is equal to 1 upon lambda anta navilli helbodu for the one wave. Suppose if you consider there are only one waves, then you can say that nu bar is equal to 1 upon lambda. That is the reciprocal of the wavelength is called as what? Wave number. Okay, so keep the, means remember this formula for the wave number. Now let us start with the derivation, students. That is for the frequency, or you can also write the derivation for the, that is wavelength also, because frequency wavelength relation ನಮಗೆ ಗೊತ್ತಿದೆ. So ಅದರ ಮೇಲೆ ಇಲ್ಲಿ wavelength expression ಕೂಡ ನಾವು ಇಲ್ಲಿ ಮಾಡಬಹುದು. So frequency or wavelength, because both we can do from the same steps. So frequency or wavelength of the radiations emitted by the electron when it takes the transitions from higher energy level to the lower energy level. So what is the expression for energy? So this derivation starts from the expression for the energy. The energy expression is equal to, it is En is equal to minus m into e raised to 4 z square divided by, it is 8 epsilon naught square n square into h square. So it is minus e raised to 4 z square upon 8 epsilon naught square n square into z square. So here, where m is the mass of the electron, so ನಿಮಗೆ ಗೊತ್ತಿದೆ m is the mass of the electron, e is the charge of the electron, z is for the atomic number, epsilon naught is the permittivity, n is equal to, it is integer, it is 1 2 3 comma, this is the principal quantum number ಅಂತ ಹೇಳ್ಬೋದು, h is the Planck's constant. So you know all these values, right? Okay, so let us see how to do the derivation. Yes, so for the derivation step, first step, when the electron jumps from the orbit N2 to N1. So electron enagta ide, it is jumping from one orbit to another orbit. So it is jumping from N2 orbit to the N1 orbit, N2 orbit to the N1 orbit. Therefore, the energy is equal to E2 minus E1 anta bariತೀವಿ. The energy expression is written as E2 minus E1. Yes. So now we know the expression for energy. ಹಾಗಾದ್ರೆ E2 ಮತ್ತೆ E1 ನಲ್ಲಿ energy expression substitute ಮಾಡೋಣ, which is equal to, so minus antu ide for the derivation. So minus id, that is m into e to the power 4 z square divided by, it is 8 epsilon naught square h square, n square is there for n2, it is for E2, we will write it as, it is n2 square minus. So already minus is there, and in the energy expression also minus is there. Therefore, minus into minus, it becomes plus. That is m e to the power 4 z square divided by 8 epsilon naught square h square upon n1 square. n1 square. So one is h square and this is n1 square. Yes, students. So now you can see what all common terms are there. Hauda? So just very simple derivation. Common enen baratte nodi. So ಏನೆಲ್ಲ common ಇದೆ? Here m is common, e to the power 4 is common, z square is common upon 8 epsilon naught square h square. So this is also common only. ಹೌದಾ? n1 n2 ಮಾತ್ರ ಉಳಿಯುತ್ತೆ. So inside bracket ಏನಿದೆ here, the remaining quantity is what in the first expression ಏನು ಉಳಿದಿರುತ್ತೆ? It is minus 1 n2 square. ಮತ್ತೆ first ಇದರಲ್ಲಿ
plus 1 by n1 square.
n1 square. Yes. So here instead of writing minus 1 upon n2 square plus 1 upon n1 square, I'll just take the plus term first. So ನಾನು ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, I'll write plus term first, that is n1 square minus, here it is 1 upon n2 square. Just rearrangement of the terms, because ಅಲ್ಲಿ minus ಇದೆ plus ಇದೆ, just interchange ಮಾಡಿದೀವಿ. Multiplication ಮಾಡ್ಕೊಂಡ್ರೆ again we are getting the previous step itself, students. Yes. Okay. So now here whatever the energy expression is there on the LHS side, so ಇದೆಲ್ಲ ಏನ್ ಬರ್ದಿದೀವಿ, energy is equal to, so this is also energy is equal to. So now I am substituting on the LHS side, energy is equal to, it is hc divided by lambda, because we know that the energy is nothing but energy of the photon. So the energy of the photon is given by h nu, which is equal to, it is hc divided by lambda, right? Because nu is equal to, ನಾನು ನಿಮಗೆ ಈಗಷ್ಟೇ ಹೇಳಿದೆ, frequency ಮತ್ತೆ lambda relation, it is nu is equal to c divided by lambda. So therefore it is hc by lambda, which is equal to, keep this term as it is, m e to the power 4 z square divided by 8 epsilon naught square h square into bracket 1 upon n1 square minus 1 upon n2 square. Okay. So now whatever this hc is there in the numerator on the LHS side, transfer it on the RHS side. So I am keeping this, ಇಲ್ಲೇನು ಉಳಿಯುತ್ತೆ, 1 by lambda ಉಳಿಯುತ್ತೆ, and hc I am transferring numerator ಅಲ್ಲಿ ಇದೆ, therefore ಈ ಕಡೆ ಬಂದ್ರೆ denominator ಗೆ ಬರುತ್ತೆ students. m e raised to 4 z square upon, it is 8 epsilon naught square h square. Already one more h is coming from the LHS, from the numerator it is coming to the denominator. ಹಾಗಾದ್ರೆ ಇದು h cube ಆಗುತ್ತೆ, ಮತ್ತೆ c ಉಳಿದಿದೆ, so c also you just take it here. So again inside the bracket it is 1 upon n1 square minus 1 upon n2 square. Okay. So now here whatever the terms are there, ಇಲ್ಲಿ bracket ಹೊರಗಡೆ, whatever terms you are able to see outside the bracket. So outside the bracket, whatever the terms you are able to see, this all terms is constant. See, m, mass of the electron constant, e, charge of the electron is constant, z, atomic number is constant, epsilon naught is constant, h is constant, c is constant, 8 is also constant. So everything is constant. Therefore, this constant I'll denote it as a capital R. The capital R is nothing but what here? It is m e raised to 4 z square upon 8 epsilon naught square h cube into C, and this R is called as Rydberg constant. You thermodynamics alli R anna, you call it as gas constant. Here it is Rydberg constant. It is nothing but Rydberg constant. Okay, so therefore now we can write it as 1 upon lambda is equal to, so this is, so Z I'll keep it as it is because Z enagatte, if you consider hydrogen atom, I'll tagolbodu, in problem illa. But as hydrogen irlilla antandre Z value will change. So for that reason, Z square I'll keep it at the same place. So Z square inside the bracket, R Z square inside the bracket, 1 upon N1 square minus 1 upon N2 square. Okay. So frequency is what, students? Illen reciprocal of wavelength ide, adu frequency agatte. Hauda? So therefore we can also write it as, because since frequency is equal to C by lambda, so here we have only lambda, therefore multiplying C on both the sides. So therefore nu is equal to R Z square into C, inside the bracket it is 1 upon N1 square minus 1 upon N2 square. So this is the final expression. So suppose if you are taking for the hydrogen atom, Z is equal to 1 agate, ಆ time Z baralla. Usually we are doing it the derivation for the hydrogen atom itself. So ಹಾಗಾಗಿ ನಾವು ಬೇಕಾದ್ರೆ time being ಇಲ್ಲಿ cancel ಮಾಡ್ಕೊಳ್ಳೋಣ. So what we have, the formula for the wavelength is what, students? Finally, the formula for the wavelength is, it is, here you can see, wavelength is given by R into bracket N1 square minus N2 square. So where R is the Rydberg constant and N1, N2 are the, from which state to which state the hydrogen is taking the, sorry, the electron is taking a jump. Yes. See, in the derivation, if you have any doubt, please ask. I'll tell you what is the Rydberg constant value. So you just see first all other terms. Very simple derivation. Only the thing is you need to remember energy formula. Energy formula gottidre just substitute ಮಾಡ್ತೀವಿ, common ಹೊರಗಡೆ ತಗೊಳ್ತೀವಿ and rearranging the terms, and that whatever the constant you have taken out, that is nothing but R, that is the Rydberg constant. ಮತ್ತೆ frequency ಅಂತ ಅಂದ್ರೆ nu is equal to C by lambda. So ಇಲ್ಲಿ nu ಬರಬೇಕು ಅಂತ ಅಂದ್ರೆ here C will be multiplied on this side. So therefore it is RC into bracket 1 upon N1 square minus 1 upon N2 square. So please copy down. If you have any doubt, please ask. I'll tell you the value of the R. I'll give you 2 minutes, copy down. Yes, completed. So the Rydberg constant, it is calculated by substituting all the values. So you can take the value here, student. The Rydberg constant R is equal to, it is 1.09. If you want one more decimal, it is 1.097 into 10 raised to 7 per meter. So remember the unit also, it is 1.097 into 10 raised to plus 7 per meter is the Rydberg constant. Yes, check. Copy down the Rydberg constant value also. When we do the numerical, it will help us for the calculation. So in some of the books, sometimes they will write it as K also. Okay. So the Rydberg constant, sometimes they denote it by K letter also. So R is equal to, please remember this value, that is m e raised to 4 z square upon 8 epsilon naught square h cube into c. ಅಂದ್ರೆ ಇಲ್ಲೇನ್ ಬರ್ತಿದೀವಿ ನೋಡಿ, ರಿಡ್ಬರ್ಗ್ ಕಾನ್ಸ್ಟಂಟ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಯು ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್ ಅಲ್ಲ ಫಾರ್ 1 ಮಾರ್ಕ್ ಆರ್ MCQs ಅಲ್ಲಿ ಕೆಲವೊಂದ್ಸಲಿ ಕೇಳ್ತಾರೆ, ಬಿಕಾಸ್ ಯು ಹ್ಯಾವ್ MCQ ಪ್ಯಾಟರ್ನ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಸೊ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು m e raised to 4 z square upon 8 epsilon naught square z cube into c. So please mark it as an important formula, because in MCQ sometimes they ask R. Confuse our chances irutte, because here 1 is having power 4 ide, 2 ide, 3 ide, all the powers are there in the R. So therefore remember this one very properly, with even though it is having some constant value. Getting? Okay. If it is clear, I'll just clean this. We will go for the next concept. Yes. Yeah, Rydberg constant value, the derivation is also important. So the next point we are discussing. So both the derivations we have seen, okay, that is for the wavelength also, for the frequency also. So remember the derivation properly. So I told you already in this chapter, the radius expression, the energy expression, and this wavelength expression. So frequency antu alli adu multiply agutte, c multiply agutte aste. So please remember all the 3 derivations. At least one derivation is fixed in the final exam. Okay, we are going for the next point, students, that is the spectral lines. So here we discuss about some of the emissions, that is the hydrogen spectrum, because Rutherford model could not explain the spectrum, but Bohr's model will explain about the spectrum. So for that reason, we are discussing about the spectrum concepts now. So let us see what do you mean by. So these are the types. Okay. So after the spectrum, some series are there. Those are the series. So that one we will discuss. First, let us discuss what is line emission spectrum. So here first we need to understand what is line emission spectrum. Yes. So what is line emission spectrum? When hydrogen gas is excited. So here purely it is Bohr's model. So Bohr's model is applicable only for the hydrogen. So therefore we are discussing for the hydrogen itself. Yes. So first the line spectrum, we are line emission spectrum. So what is line emission spectrum? When hydrogen gas is excited, the electrons of an atom jumps to different higher orbits depending upon the quantity of the energy. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಅಂದ್ರೆ hydrogen gas ಏನಿದೆ, when this hydrogen gas is excited, so ಯಾವಾಗ hydrogen gas excited ಆಗುತ್ತೆ, that time the electron will jump from one orbit to other orbit. So it will jump from one orbit to other orbit. So while returning to their lower orbit, so ಕೆಳಗಡೆ orbit ಅಂದ್ರೆ higher orbit ಇಂದ lower orbit ಬರ್ಬೇಕಾದ್ರೆ, this electron will emit some energy. These electrons will emit some energy of different wavelength, So this type of spectrum is called as what? Line emission spectrum. This type of spectrum is called as what? Line emission spectrum. So in this line emission spectrum, we are able to see both bright and dark background. So both light and dark background, ಎರಡೂ ನಮಗೆ ಕಾಣಿಸುತ್ತೆ. So that is for the line emission spectrum. So what is line emission spectrum here, students? That is the hydrogen gas is excited. It will emit some energy of different wavelength. So whatever the from higher energy to lower energy, when it is coming, it will emit some energy. So whatever the energy is released, that energy released is called as what? Photons anta ಹೇಳ್ತೀವಿ. So this type of phenomena is called as what? Line emission spectrum. So here what all key terms you need to remember here, students? The key terms are, that is, first thing is the hydrogen gas ಏನಾಗಿರ್ಬೇಕು? The hydrogen gas must be excited. This is the first step which is required for the line emission spectrum. Second step is what? In the second step we say that here, depending on its energy, it will take a transition, or it will jump from higher orbit to lower orbit. It will jump from higher orbit to lower orbit. The next point is what? So while coming from higher orbit to lower orbit, it will emit some radiation. It will emit some radiation. So that of different wavelength. So this type of spectrum is called as what? Line emission spectrum. So these 4 points you need to remember. The hydrogen gas must be excited. It should move from higher orbit to the lower orbit, and when they're coming from higher to lower, it will emit some radiations of different wavelength. This phenomena is called as line emission spectrum. So line emission spectrum speciality ಏನಿದೆ ಅಂತಂದ್ರೆ, it consists of both bright and the dark background. Both bright and dark backgrounds will be there. Yes, is it clear? What is line emission spectrum? So the next one is line absorption spectrum anta kuda baratte. So if you understand emission spectrum, absorption spectrum will be easy. Yes. See, students. So now we discussed about the emission spectrum. The next point we are discussing is absorption spectrum. Next point is line absorption spectrum. Here what happens in the absorption spectrum? When white light of continuous spectrum is passed through the cold hydrogen gas. So illi first point in ನೆನಪಿಡಬೇಕು. Here ನೀವೇನ್ energy ಕೊಡ್ತಾ ಇದ್ದೀರಾ, that is passed through the cold hydrogen gas. It is passed through the cold hydrogen gas. Here what happens? Some dark lines are seen. So that time some dark lines are observed. So that is nothing but the dark lines spectrum we are observing. So this type of spectrum is called as what? Absorption spectrum. This type of spectrum is called as what? Absorption spectrum. And in the absorption spectrum, we are able to see only the dark lines. So tomorrow I'll show you how the this absorption spectrum and the emission spectrum will look. Okay, I'll just display those diagrams here. So in the emission diagram, we have both the bright and the dark lines. In the absorption spectrum, we have only the dark lines. And the difference in those phenomena, both the phenomena is, that is white light. Here we are passing the white light is passed through what? Cold hydrogen gas. So white light through cold hydrogen gas pass ಮಾಡಿದಾಗ ನಮಗಿದು absorption spectrum ಕಾಣಿಸುತ್ತೆ. Yes, is it clear, students?
Yes, ma'am.
So hagadre one question, one very small question, that is, what is the cause? What is the cause for emission spectrum? What is the cause for the emission spectrum? ಏನಂತ define ಮಾಡಬಹುದು ನೀವು ಇಲ್ಲಿ? What is the cause for the emission spectrum? Cause ಅಂತಂದ್ರೆ ಏನು? Reason why that is taking place. Emission spectrum. What is the cause for the emission spectrum? Yes, what is the cause?
Excitation of the hydrogen gas.
Yes, yes. So here what happens? That is the hydrogen gas. It is in an excited state. For that reason, the electron transitions takes from higher energy to lower energy. So that is the reason for this emission spectrum. Okay, that is the reason for the emission spectrum. Yes, that is the correct answer. So 1 mark sometimes they will ask, or they may ask it in the MCQs also. So the cause is the excitation of the hydrogen gas. For that reason, the electrons jumps from higher orbit to the lower orbit. Okay. So the next point we are discussing now. Yes, what is the next point? C. Yes, the next one. So here we discussed about that is the spectrum. So in the spectrum, we have some of the series. Okay, so some series we are getting. So we are studying with the 5 series here, students. You need to remember in the sequence. The first series is, it is the Balmer series. The first series is called as what? Balmer series. So idella enide scientist name mele idella series anna name madidare. So who invented which series? Based on their name it is given. So the first one is not by Balmer, sorry, it is a Lyman series. The first series is a Lyman series. It is Lyman series. The second one is the Balmer series, Lyman series, Balmer series. The third one, it is the Passion series. Fourth one, it is Brackett.
Bracket series.
Then the last one is Peapod. So these are the 5 series here, students. Okay. So total we have the 5 series based on the yes, so total we have the 5 series, Lyman series, Balmer series, Passion series, Brackett series, and the P-Fund series. So these are the 5 series here, students. So here we have the empirical formula for the wave number of different spectral lines. Okay. So ಈಗಷ್ಟೇ ನಾವೇನ್ wavelength formulas ಅನ್ನ ನೋಡಿದ್ವಿ. That is wavelength is given by what? 1 by n lambda is equal to, it is r into bracket 1 upon n1 square minus 1 upon n2 square. So with respect to different series, illen bere bere series anna nodta iddivi. With respect to this series, we can substitute the value of n1 and n2. Adanna series limit anta heltivi. It is called as the series limit. Okay. So let us see for the first line of all the series, what is the value of n1 and n2? Very simple, very easy to remember. But elladrikinta munche you have to remember the series sequence: Lyman, Balmer, Passion, Brackett, and the P-Fund. So if you forget that, it is very difficult to ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಮಿಸ್ಟೇಕ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಬಿಕಾಸ್ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ n1 n2 ವ್ಯಾಲ್ಯೂಸ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್. ಸೊ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಮಿಸ್ಟೇಕ್ ಮಾಡಬಾರ್ದು ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದ ಸೀಕ್ವೆನ್ಸ್. ಎಸ್. So here many points will cover. So today we are discussing only the n1 n2 value. The first one is the Lyman series here, students. So for the Lyman series, here the electron takes a jumps from higher orbit to the first orbit. Therefore, the n1 is equal to, it will be 1, and the n2 value will be, it is 2, 3, 4, 5, so on up to infinity. Andre n2 andre higher orbit irutte. n1 is what? Lower orbit. So Lyman series yavag barutte? When the electron takes a jump from higher orbit. Higher orbit yavdu irbodu? Second irbodu, third irbodu, fourth, fifth, up to infinity ಯಾವ್ದಿದ್ರು ಕೂಡ. If it is taking a transition to the first orbit, the Lyman series we are getting. So ನೀವೇನಾದ್ರೂ formula ಬರೆದ್ರೆ, if you write the formula for that lambda, it is 1 by lambda is equal to r into bracket 1 upon 1 square minus 1 upon n2 square. This is lambda value. This is for what? Lyman series. Hagadre, next we will go for the Balmer series, students. So for the Balmer series, here N1 is equal to 2
2,
and N2 is equal to, it will start from, that is
3,
3,
4,
4,
5.
5, so on up to infinity. Yes, understanding the difference? See, N1 is equal to 1 irutte Lyman series alli, Balmer series alli N1 is equal to 2 barutte. So Lyman series N2 is equal to 2 adaga 2, 3, 4, 5. Illi Balmer series alli N2 2 ಇಲ್ಲಿ already N1 igide, so the remaining values will be the higher orbits 3, 4, 5 up to infinity. So similarly for the Passion series, so all the series here we will write it one box. Maybe here it is there, I think. Yes, here you can see here, students. So for the Lyman series, N1 is equal to 1, N2 is equal to 2, 3, 4 up to infinity. For the Balmer series, N1 is equal to 2, N2 is equal to 3, 4, 5 up to so on. Passion series, N1 is equal to 3 and the Passion series, the higher value will be 4, 5, 6, so on. Bracket series, P fund series. Yes, see that. See if any confusion is there in the series, please ask. So in the same slide, you are able to see this series lies in the, so illen series ide, this series lies in the ultraviolet region. Yavdu? That is the Lyman series. So here we have the that is ultraviolet, EM waves, infrared, IR, that is visible region. So we have different regions in the electromagnetic waves. We have studied this. So total 7 spectrum baratte. Adralli Lyman series edral baratte nodi student, that is in the ultraviolet region. Then the Balmer series in the visible region, Passion series in the infrared region, Bracket series infrared,
Infrared.
and P fund also it is in the infrared.
Infrared.
Actually ಅದು ಏನಾಗುತ್ತೆ, higher infrared region, middle infrared region, lower infrared region ಅಂತ ಬರುತ್ತೆ. So if you want that clarification also, here I can write that. So whatever the Passion series you are seeing, this is only near infrared, ಅಂದ್ರೆ just infrared ಎಲ್ಲಿ beginning ಆಗುತ್ತೆ ಅಲ್ಲಿ ಇದು Passion series ಬರುತ್ತೆ. And for the bracket will be middle of the infrared series, and the P fund will be far and the lastly end of the that is infrared region. So Maton 6th series ide, still the studies are going on. That is not there for you, just for your general knowledge. You can just remember Humperi, HUMPHERY. That is the one more series is there. So after P fund we can see this series. Still the studies are going on. Here N1 is equal to 6 anta baratte, and N2 values will take from 7, 8.
7, 8.
And ಇದು ಯಾವ region ಅಲ್ಲಿ ಬರುತ್ತೆ ಅಂದ್ರೆ, it is in the radio waves. It is in the radio waves. Yes, students, any doubt is there?
No, ma'am.
Okay. Okay, so here some more points we will discuss regarding this spectral lines. So what does that see? That is, so here suppose the electron jumps from nth orbit. If the electron jumps from nth orbit, how many possible spectral lines will be there? How many possible spectral lines will come? So to calculate the number of spectral lines, we have the formula, that is n is equal to n into bracket n minus 1 divided by 2. So this is the formula to calculate what? That is the nth orbit, or when the electron jumps from nth orbit, how many number of possible spectral lines will be coming out. So yes, number of spectral lines is there, that is n is equal to n into bracket n minus 1 by 2. So small n is the number of possible spectral lines. So you can say ಇದು ಯಾವ excitation orbit ಇದೆ. So first, second, third, you can substitute that value, n value. You will get number of possible spectral lines. So this is one shortcut formula. Please take down this formula. Yes, that is formula is what? N into bracket. N is equal to N into bracket N minus 1 divided by 2. That is the number of possible spectral lines emitted. Okay. So here one more point you remember which will help for the numerical part, student, that is, so here we have the spectral line series, that is the Lyman series, Balmer series, Paschen. Then we have the bracket, Pfund. Okay, so these are the series we have. So first line, or if they are asking you to calculate the longest wavelength. So suppose longest wavelength ಏನಾದ್ರು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ, ಕ್ವಶನ್ ನೋಡಿದಾಗ ಅರ್ಥ ಆಗುತ್ತೆ. Now you just take down the values. Suppose if they are asking for the longest wavelength, that is N1 is equal to 1, N2 is equal to 2. Balmer series, N1 is equal to 2, N2 is equal to 3. Paschen series, N1 is equal to 3, N2 is equal to 4. And bracket series, N1 is equal to 4, N2 is equal to 5. Pfund series, N1 is equal to 5, N2 is equal to 6. This is for the longest wavelength. Okay. So then barditkolli, which will help us for the numerical calculation. So if they are asking you for the longest wavelength. The second column, suppose if they are asking for the last line or the shortest wavelength anta helbodu, and for the series limit anta enadru question alli idre, calculate the series limit. ಆವಾಗ N1 N2 ವ್ಯಾಲ್ಯೂಸ್ ಏನ್ ತಗೊಳ್ಬೇಕು ಅಂತಂದ್ರೆ N1 ವ್ಯಾಲ್ಯೂ ಇಸ್ ಸೇಮ್, ಇಲ್ಲೇನ್ ಬರ್ದಿದ್ದೀರಾ ಅದೇ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ. ಸೊ N1 ವ್ಯಾಲ್ಯೂ ಇಸ್ 1 ಫಾರ್ ಲೈನ್ಮನ್, ಬಾಲ್ಮರ್ 2 ಬರುತ್ತೆ, ಪ್ಯಾಷನ್ 3, ಬ್ರಾಕೆಟ್ is 4, Pfund is for 5. But the N2 value in all the cases you have to consider it as infinity. N2 value is what? It is for the infinity. Yes. So just note down this. You will understand when we do the question. Just copy down the points. If any doubt is there in the today's class, please ask students. So this one you note down. While doing the numericals, you will understand how to use it.
Completed, ma'am.
Okay. Okay. If any doubt is there, please ask. Otherwise, we will meet in the next class with the spectral series, few more points. Okay. Bye, students.